All right. Let's first review the basic trig functions. For y equals sine x, y equals cos x, we will focus on key points, max, min, intercepts, right? There's 5 key points for each cycle. For y equals tan x, we will focus on 3 key points actually and the 2 asymptotes. So graph y using sine x using key points. Note that the period is 2 pi. Special points occur every pi by 2. There's a max, a min, and the 3 intercepts. The amplitude is 1. So do you remember when theta or x, I'll call it sine x today. We're just going to graph y. Well, they called it x. So this should be labeled x. This should be labeled y. When x is 0 degrees or 0 radians, well, we're talking about 2 pi here, so we'll talk in terms of radians. What is y? What is our starting point? 0? Huh? 0, 0, right? And then every pi by 2 we have a key point. So this is going to be pi. This is 3 pi by 2. This is going to be 2 pi. We can extend this. So if this is 4 pi by 2, this will be 5 pi by 2, right? And this will be 3 pi. So this is the same as 6 pi by 2. So this is 7 pi by 2. And this is going to be 4 pi. If we were to go in the negative direction, we could go indefinitely that way. Negative pi by 2, negative pi, negative 3 pi by 2, and negative 2 pi. Okay, so it starts at 0, 0. Then at pi by 2, sine is 1. Then it comes back down, right? This is 1. This is negative 1. And it goes up, up, down, down, up. And then we continue the pattern on this side. Okay, so notice the domain is x such that x is any element of real numbers. Even though we're talking about radians, the radian measure like pi by 2, these are all real numbers. And our range is y such that negative 1 is less than or equal to y is less than or equal to 1. Y is the element of real numbers. So notice the special points occur every pi by 2. Actually, special points will occur every period divided by 4. This would be a general rule of thumb even when we're stretching horizontally and we have phase shifts and so on. So if in this case our period is 2 pi, the length of the cycle is called the period. So whether I measure it from there to there, there to there, right, one complete cycle, the period is 2 pi divided by 4 equals pi by 2. So notice the special points occur every period divided by 4. I'm just making you aware of a new little equation that will help us out in today's lesson. Okay, so that's basically y equals sine x. Now, we're going to do y equals cos x in a similar manner. Again, the special points will occur every 2 pi by 4, which is pi by 2. Notice that's why we say it occurs every pi by 2. We have a max of 1, a min of -1, just like we did for sine. The amplitude is max minus min divided by 2, and in this case it's 1. So again, we have the very same thing as far as our, this is x, this is y, 3 pi by 2, 2 pi, 5 pi by 2, 3 pi, 7 pi by 2, 4, right? I could go over many cycles in the left direction. We'll just do one. Minus pi by 2, minus pi, minus 3 pi by 2, minus 2 pi. Okay, so what's our starting point for the cosine function? 1, right? When there's 0 radians, the cosine of 0 is 1. So notice now it's just going to come down, and it's the same pattern actually as the sine function. Don't forget to scale. Make sure you put your scale here on the y-axis. And then we'll continue the pattern here. Oh, I jumped one. The negative 3 pi by 2 should be there, right? I just accidentally went over 3 instead of 2. Now there, my whiteout's a little bit slow here. I'm going to fix that here, right here. So we get, this is negative 3 pi by 2, and right here is negative 2 pi. So just be careful of that. I made a boo-boo. Okay. Okay, so it looks, it's actually congruent to the sine function. The only difference is, if you look at sine, the cosine function, it's like sine's been shifted to the left by pi by 2 units, and we get what looks like our sine function. Okay, so again, the domain is x such that x is an element of real numbers. Our range is y such that negative 1 is less than or equal to y is less than or equal to 1. Y is an element of real numbers. Okay. Sure. No problem. No problem. Okay, so the y equals tan x is a little bit more complicated. The period is pi, right? Y equals tan x. There's asymptotes and key points. The period is pi. Special points occur every pi by 4. Notice special points occur every period, which is pi divided by 4, or pi over 4. Now that's bound to change when we do horizontal stretches and compressions. But for now, just note this special little formula, period divided by 4. So the amplitude does not exist because y goes from negative infinity to positive infinity. So let's do our x here. Let's do our y. So the special points and asymptotes together, or our special characteristics, occur every pi by 4 because the period is now pi. That should be a 4 right there. I'll just write over it. Okay, so we have an asymptote at negative pi by 2. We have one at positive pi by 2. So tan of 0 is 0. tan of pi by 4 is 1. We'll put a 1 there and a minus 1 there. Right? And so there we go. There's our y equals tangent function, just like that. Now, you know, these functions are periodic. So there again, the tan function is periodic. That means it repeats every cycle, every period the cycle repeats. Similarly here. So we use 1, 2, 3, 4, 5, 6, 7, 8. We used 8 spaces for a complete cycle. So we could draw another one here. So we'll just add this point's going to be 3 pi by 4. This is going to be pi. This is going to be 5 pi by 4. And this is going to be 3 pi by 2. Okay, so again you have the same pattern as we had before. And we could do it in the negative direction as well, but I won't belabor the point. So, remember we have asymptotes. Now our asymptotes occur at every pi by 2 plus any multiple of k pi, whether we add, notice we have an asymptote at pi by 2. If we were to subtract pi, we'd get negative pi by 2. If we were to add pi to pi by 2, we'd get 3 pi by 2. And k is an element of integers. It could be a positive multiple or a negative multiple. So that means our domain is more complicated than sine and cosine because we have these asymptotes. So x cannot be pi by 2 plus k pi, where k is the element of integers and x is the element of real numbers. And our range is easy. Range is y such that y is the element of real numbers. So that's a review of what we did yesterday. I can't overemphasize, you need to know this well so you get the graphing, the transformation portion of this unit. Can I flip it over or do people still need this? Okay, so vertical stretches. So now what we're going to do is, this is a review of Unit 3. Vertical stretches and compressions in this unit with the trig functions are indicated by A. So we could have y equals 3 sine x, or y equals negative 4 sine x, or y equals a quarter sine x. So you could either stretch it vertically by a factor of a or compress vertically by a factor of 1 over a. We could have horizontal stretches and compressions as well. So if the absolute value of k is greater than 1, so basically remember, well, let's just look at this. Either a is greater than 1 or a is less than negative 1. And this is just saying negative 1 is less than a is less than 1. Okay? here we're saying either k is greater than 1 or k is less than -1. It's a short form to write both of these things. And this guy is saying -1 is less than k is less than 1. Again, we could have reflections about the x-axis, and we can have reflections about the y-axis as well. So the way we're going to do transformations in this unit is very different. And it's called fitting the axis to the curve. We draw the curve first, and then we put on the axis. This is terminology I'd like to go over with you. We talked about it. Period is the horizontal length of one cycle. A cycle is one complete pattern of a periodic function. A periodic function, like the three functions we just drew, is a function that has a pattern of y values that repeat at regular intervals. An amplitude is basically your max minus min divided by 2. In other words, it's half the distance between the max and min points. Okay. Graphing transformations as sine and cosine and tangent functions are going to be handled differently than graphing as a series of transformations. We're going to talk about this method. The method is called fitting the axis to the curve. I think you can imagine that sketching something like this would be very difficult. Our period would be 25. It would be 2 pi divided by k. We'll talk about these formulas in a moment. And the amplitude here is 5,000. It's a bit too much to do, by using a series of transformations. So I'm going to show you this method. I think you'll like it much better than what we did in Unit 3. Oh, gotta flip the page. Let's just do a couple of examples. So, when you have a trig function in this form, y equals sine a sine, open bracket, kx, close bracket, or y equals a cos, open bracket, kx, close bracket, the amplitude is a. The period is, normally the period for the sine function is 2 pi, but if there's a k, we have to divide it by k. And special points occur every period divided by 4. We talked a little bit about this previously. Now for cos, it's a little bit different. I mean, for the tangent function, it's a little bit different just because the period for the tangent function is not 2 pi, it's just pi. So the amplitude is undefined. A still vertically stretches or compressions the graph, but there's no amplitude because there's no max and there's no min. The period is pi divided by k, and the special points occur every period divided by 4. So the period in this case is pi divided by k. Let's do an example. Okay. Here, A is 4, and the amplitude is 4. Okay. K is 6, right? Right there is our K. So the period is 2 pi divided by 6, right? Normally the period for the sine function is 2 pi. We divide it by K, so this equals pi by 3. I'm just reducing it to lowest terms. Special points occur every period divided by 4. So it's going to be pi by 3 divided by 4. So special points are going to occur every pi divided by 3 time multiplied by the reciprocal. So special points occur every pi by 12. Note A is positive, so there's no reflection in the x-axis. K is positive, and there's no reflection vertically over the y-axis. So there's no movement. There's no horizontal or vertical translation, so the origin does not move. So let's just graph that so you can see what we mean. We'll draw the y-axis here. We're just going to graph one period. So it's x here. So there's a vertical stretch here by a factor of 4. So instead of going up 1, it's going to go up to 4. 1, 2, 3. Well, we don't even have to do that. We can just go, we'll call that 4. We'll call this negative 4, because that's, instead of going up to 1, it's going to go up to 4. Now, special points occur every pi by 12, so this is going to be pi by 12. This is going to be 2 pi by 12, or pi by 6. And this is going to be 3 pi by 12, right? 1 pi by 12, 2 pi by 12, 3 pi by 12, which is pi by 4. And then we're going to have 4 pi by 12, which is pi by 3. I'm just reducing everything to lowest term, right? Pi by 12 plus pi by 12 equals 2 pi by 12 is pi by 6, right? So that's pi by 6. So see how I'm adding pi by 12 to each one? Pi by 6 plus pi by 12. You don't have to do this. Is 3 pi by 12, which is pi by 4. But I just thought for those of you who need to see a little bit more mathematics, there it is. So there's no reflection, so here we have there's our starting point. It goes up to 4, back to 0, down to minus 4, and back up. So there is one complete cycle of y equals 4 sine 6x. Isn't that easier than what we used to do? It's nice, huh? I love this method. Let's do a number of examples. We need to at least do a tangent one with you. Let's do the first 3 examples, and then you can I'll walk around and watch you do a few examples by yourself. Yes, I guess y equals. Good point, thank you. Let's do this one. Is there anything you'd like me to go over? Okay. All right. Notice A is negative, so we have a reflection over the x-axis. So A is -3. Therefore, the amplitude, which is always positive, is 3. K is 1/3. So period 2 pi divided by 1/3 is equal to 2 pi times 3/1 equals 6 pi. So the period is, there's a vertical stretch, right, by a factor of 3. Instead of the period being 2 pi, the period is now 6 pi. 2 times 3 is 6. So there's a horizontal stretch by a factor of 3, a vertical stretch by a factor of 3, and a reflection over the x-axis. So the special points occur every 6 period, right, divided by 4, which is 3 pi by 2. So let's graph it. So the first special point will be at 3 pi by 2. Then we add 3 pi by 2, which is 6 pi by 2, which is 3 pi, right? 3 pi by 2 plus 3 pi by 2 equals 6 pi by 2 equals 3 pi. Now to get the next point, we go 6 pi by 2 plus 3 pi by 2 equals 9 pi by 2. Right? So this one, the next special point is going to be 9 pi by 2. So 9 pi by 2 plus 3 pi by 2 equals 12 pi by 2 equals 6 pi. Right? So that's our period. We have a complete cycle within 6 pi. Now, the cosine, well, our max, it's stretched, vertically stretched by a factor of 3. Our max will be 3, and our min will be -3, right? Normally it goes to 1. Normally it's from +1 to -1. But we have a stretch, by a vertical stretch by a factor of 3. And so notice, sine usually starts up here. No, I mean cosine usually starts at 1, or in this case 3, but there's a reflection. So where will my starting point be? -3, right? We have a reflection, but the rest will be the same. Now we just follow the pattern. Let's try a tangent function that's been stretched, etc. Remember, the tangent function has no amplitude. We're going to be graphing y equals 2 tan 1/2 x. So a equals 2. So we do have a vertical stretch by a factor of 2, right? K equals a half. So remember, tangent, normally the period is pi, but we're going to go pi divided by 1/2 is going to be pi times 2 over 1, right? When you divide by a fraction, multiply by this reciprocal. So the period is going to be 2 pi. Special points occur every 2 pi by 4, and that is pi by 2. Oh, I drew it wrong. You know why? We have to be more in the middle. So I apologize about that. For the tan function, yeah, I'm sorry. We just have to be more in the middle. What can I say? Let's just put it more in the middle. My humblest apologies. Now, the period is 2 pi, so half of it will be on this side, 1, 2, 3, 4. This is pi. And half of it will be on this side. So this will be special points every pi by 2. There's no reflection. We have a vertical stretch by a factor of 2. So normally we go up 1 at this midpoint. Instead, we're going to go up to 2. Right? Do you see how it just follows the pattern of before? There's been no reflection, so it'll still look like this. Can I answer any questions? So what I want you to do is try 4 and 5, and then we'll take them up. I'm just going to walk around, see if you have any questions, and just make sure you're good with this material.